Friends, welcome to our homestead. Behind me is our solar power system for our home. You've seen this system before, but today we have something brand new for you. And this new inverter is going to make it a lot more affordable for people to initially get into solar for their home. Let's talk about it. This is the new Eg4 6000 XP inverter, and it has lowered the barrier to get into solar because it does split phase. That means it can output 120 volts or 240 volts. So you can run large loads in your house, like a water heater, a dryer, or a stove, without having more of these. You just need one. With single phase inverters like the 6500EX, you have to have two if you're going to run those 240 volt loads in your house. And if you want to expand these for more power, you have to expand them in pairs. So you're spending money on two, and then if you need to expand, you have to buy two more, so four. With the 6000 XP, you can expand by just one, or two, or three. It does not matter. You can have odd numbers or even numbers. And you can actually parallel up to 16 of these together for 96 kilowatts of inverting power. I don't know too many people who need that much, but if you have 3 or 4 families living together, you can do that off of one system. There are other features on here which make it more affordable as well, and I'll talk about those in a minute. But having just one, if you're off-grid in a cabin, this is all you're going to need, is 6,000 watts or 6 kilowatts of inverting power, and you can pretty much run absolutely anything. But for my 1,800 square foot home where we have a lot of modern electrical appliances, I need 2 of these, and that'll be perfect for us. And because it's split phase, you can choose however many you need. 1, 3, 5, 6, it doesn't matter. Let's look at some other features that are integrated into this that will save you some more money. As you can see at the bottom of the unit here, we have got breakers, and these are integrated into the entire package, and this is nice. Usually, here's the battery breaker. This is a 200 amp breaker. Usually you have these separate or external, and on my 6500EX system we have those externally on there. Some people use a T-class fuse, some people use breakers, but this integrates this breaker, which is really nice. And over here on this side we've got AC breakers. We've got our load, which is our line out. We've got our grid, or our line or AC in, and we've got our generator. And that is super nice to have. It kind of streamlines things for you and prevents you from having to buy them separately. Let's take off the cover here and we can see some of the internal workings. This is nice here. They've got these integrated dry ports, and you can use these to control things like rapid shutdown or other things like that. So that saves you some money from an external system that would do the same thing. Then you also have an integrated PV disconnect here. Here are the PV inputs for both MPPTs, and you have 2 MPPTs in this unit which can handle up to 8,000 total watts from your PV array, 4,000 on each MPPT. And since you have AC breakers integrated into the unit, you also have a neutral bus bar here at the bottom and a ground bus bar. On my 6500EX system, you can see I have this external Nader 200 amp breaker here and the enclosure around it. So all that in total was about $100. I also have this IMO PV disconnect switch, which runs you about $100 as well. So with one system, you are saving about $200 with both of these. That doesn't include those dry contact ports that are integrated into this as well. With the AC breakers in here, that does give you the ability to not use a sub panel, but I wouldn't recommend it. Having the controllability of this sub panel, I think, is really important in the way that we've designed our system and for most systems. But it is nice and it is safer to have the extra controllability on the unit itself. So I'm going to show you everything you need to know to connect this new inverter to your home. But first I need to take these off and repurpose them somewhere on my homestead. And for anybody who's wondering, they are working perfectly now and power the house with no problems at all. Let's get to work, and while I'm hanging the 6000 XPs on the wall, I'm going to talk about some of the design features that can be challenging and some that are really nice. When you're disconnecting or reconnecting anything on your solar power system, make 100% sure that all of your battery breakers are off everything's turned off, your PV disconnect is disconnected either at the panels or in here, and check everything for voltage with a voltage meter. Another feature I like about the 6000 XP so far is that you don't have these wires you need to disconnect if you need to get inside and work on anything. You can just take that bottom cover off and you don't have to mess around with the screen like this. One down. And number two. The next thing I'm going to do is clean up this sub panel. If you choose to have the sub panel, you will need a 40 amp breaker for each one of your 6000 XPs. So I will take out this 70 amp breaker and the 4 gauge wire that was coming from the AC out from our 6500 EXs, and I will replace them with the 40 amps and some 8 gauge wire. Now 6 gauge will fit into the 6000 XP, so if you want to bump up your wire size, you absolutely can do that. And the rest of this I'm going to leave the same. So this is 4 gauge wire and it's running back to our main service panel, which is about 55 feet away. So having the bigger wire is important. And that runs back to a big breaker, a 70 amp breaker on that panel, and that has a generator interlock kit on it. I also have the safety switch in between those 2 points as well. Now that everything's off the wall, we can mount our new 6000 XPs. It conveniently comes with a template that is marked with the holes that you need to drill out. Now what I've also done is marked the level at which the screen is on the actual inverter, because I don't want to put that too high and not be able to reach it or read it. So it's going to have to come at an eye level on the wall. Now that's something that's a little bit challenging about the design, because if you have your screen at eye level, your cable entry on the bottom of the inverter is going to be fairly low on the wall. I'm 5'10", so it's not that big of a deal, but if you're shorter, you're going to have to mount it a little bit lower so you can manipulate the screen. That means you're going to probably have to kneel down to put your conductors into the bottom of the inverter for the connections. Now these are a transformerless design, and what that means is they're a little bit lighter. However, they are still pretty big and they do weigh about 54 pounds, I believe it is. They do come with handles on the side, so it is easier to pick them up and mount them on the wall. But unfortunately, you probably are going to need 2 people. And the reason for that is the mounting holes at the top are a fairly thin oval shape, and a lot of the mounting screws that I found were just not thin enough to get through that hole. So we're going to have to hold it up on the wall, one person, while the other person puts in the mounting screws and gets it secured to the wall. Maybe I will just take a drill and modify this hole a bit. We'll see. Additionally, in terms of mounting these, it's very similar to all other inverters like this. It's about 20 inches from the ceiling and about 8 inches apart from one another. We got them on the wall. It wasn't that difficult, but you definitely need 2 people. Let me show you what else came in the package with each inverter. First, the manual. And this is probably the best manual that Eg4 has ever put out through all the products that I've gotten from them. And it's color and it's comprehensive, and it has a lot of stuff, and it's large so you can actually read it. So great. We've also got a battery comms cable, and if you want to do communications, you can. This is the battery comms cable. This is the paralleling cable that you will use for more than one inverter, obviously. Then we also have the Wi-Fi dongle if you want to use that. And in the bag, we've got a little bit of hardware. We've got some concrete anchors. We have our battery connecting bolts. There's a couple of them. They're actually quite small, which is a little weird, but we've got that. And then we've got a few tiny little bolts that will connect and secure your Wi-Fi dongle onto the side. I have the DC side of things wired on what's going to be our master inverter, and let me show you what I've done so far. So I'm not going to touch these, but you can see we've got our positive battery cable to the positive, our negative to the negative. Make sure your breaker is off when you're connecting this. I have not found anything big enough to actually go in this opening, so I will continue to search, but of course I'm going to protect these wires in this opening. Over here we have our positive and negative PV wires connected to our number 1 MPPT, and our disconnect here is off. This is one of the PV wires for the other inverter, and we have elected to use ferrules, It's just easier to get them in these really small terminals that they have here. And if you've never seen a ferrule, they come in a kit with a crimper like this, and this crimps them onto the wire. And I'll list all these in the description below the video. Make sure you're working with this. You've got some really tiny screwdrivers because that's what's needed to connect most of these. Make sure when you're connecting your PV that you do not go over the 480 volt limit on the MPPTs. So these have a little bit lower voltage limit than the 6500 EXs, which were 500 volts open circuit. Make sure you are careful when calculating your PV. Actually, before I put these in, I had to go out and rearrange some of the wiring on my array because the voltage was just too high for these. If you go to this website right here, it's really great at helping you calculate what your voltage will be per your panel. They have a lot of panels calculated into that site. The solar evers that I use are calculated into that site, and the temperature for your area will be calculated in there, and that makes a big difference. Now let's get the DC side wired on this other one, and then we'll start on the AC wiring. And remember, I always have every part and piece that I use listed in the description below the video, so you can go check those out. The torque specifications for these are contained within the manual. No matter how many redundant controls I have on my system in terms of breakers and disconnect switches, I always tape the ends of my PV wires and most other things just to be safe. So let's get this electrical tape off here. That way, if it happens to come in contact with something, I'm protected a little bit with that tape. Of course, always tug on your wires to make sure they are solidly seated in those terminals. And before anyone comments, I do have conduit for my PV lines that I will install soon. Now before I run the parallel cable, I am just going to do an initial startup on each one individually. Then we'll get that AC wiring in. So if I didn't mention before, your PV voltage coming into each inverter needs to be at least 140 volts for operation to begin. And you will need at least two 100 amp hour batteries for this to start up and operate properly on battery. So for us, we run the version 1 Eg4 LL batteries. I will be turning two of them on initially to start things up. We'll get this cover on for safety, and then we will start up the inverters. I don't know what the deal is with all these inverter companies, but these tiny screws on these front covers have got to go and be replaced by something bigger. So the first thing we're going to do is turn the breaker on the inverter, the battery breaker, which is the one here on the right. Second thing we're going to do is turn on our batteries, the breakers on the batteries first, not the BMS switch. That lets those pre-charge resistors work and that inrush of current go to our inverter. Now we're going to turn on the BMSs for these two batteries. Now we're going to turn on the inverter. Here's our power on the right side. I'm going to turn it on. The screen should boot up here. And there we go. So we've got our PV here. We're going to turn that on and see what it tells me. So on the display here, you can see I've got 366 volts of PV, and it kind of cycles through everything. So you can see I've got a warning happening here, and I've got a little kind of sad face and a 00 code, and this is blinking, and that means battery communications. This is set for lithium ion battery right here, but I don't have the comms set up. So what I'm going to do is go in and hold that down for 3 seconds, go to this setting and set that for just regular battery, which is a lead acid battery. And it should clear that fault. Now that I did that, you can see it's got a battery voltage. You just heard it kick on, and it's probably charging the batteries at this point. And it says lead acid. It's got a little smiley face. It's nice. You can see a little solar right here, and it's putting it into the inverter and then charging straight through to the battery. I obviously don't have anything on the grid connected, and there is no other AC connected either. And on the batteries, you can see that we are charging on both of them. We got them both up and running, and that's great. They're both charging the batteries. You can hear the fan going, and it's not exceptionally loud like it was with the 6500 EX. So this port on the left side is the battery communications port. With the wire, it does come labeled battery communications. We did find a grommet to fit our hole for our communications. So we're just going to plug into this port, and then we're going to plug into the RS485 port on our version 1 LL batteries. For the main battery on your stack that's communicating with the 6000 XP, you want all the dip switches in the up position. But I'm going to tell you, you're probably going to need a firmware update just on this master battery. And you need to have a special cable to do that. Once the firmware is updated just on the one battery that communicates with them, then you don't need to do all of the other batteries. All that firmware does is add an extra protocol that will give this battery the ability to communicate with the 6000 XPs. If you don't have the cable to update your firmware on your master battery right away, then you cannot set your inverters on setting 3 to lithium ion. You need to set it to lead acid like I showed you before, but there is an extra step in there that you need to do. And that is set the number of amp hours for your entire battery stack. 600, 1200, 900, however many batteries you do have, that's what you need to set that to. And that way, the inverters will understand some better charge parameters for your batteries. Now, I've tested this, and the voltage is what it's going to read, not the state of charge. The voltage is pretty dead on with the batteries. It's only off by maybe 0.1 or 0.2. Now we're going to set up the paralleling cables so we can get these working together. I'm going to bring you in close so I can show you. So right here are 2 dip switches on every inverter. On your first and last inverters, you need to have these 2 dip switches up. From your first or master inverter, you're going to start in the right bottom port. We're going to come to our second inverter, which is our last inverter, so the dip switches will also be in the up position. Since we started in the far right port of the other one, we're going to come into the middle port on this one. And since this is the last inverter in our system, we need to loop back to the first or master inverter. So to do that, we are going to plug into the far right port on our last inverter and loop it back to the middle port on our master inverter. And we're back here on our master inverter. We're going to plug in from our last inverter into the middle port. After you've connected the cables, you want to hold this down for 3 seconds, hold the enter button down, get into your protocols and go to setting 21. Once you're at 21, enter in. You're going to see the parallel flashing at the top. You need to have this in one phase or 1 pH. From there we can enter in. Now it says phase. You want to be in phase 1. You want battery share enabled when you hit the enter again. For your host inverter, you're going to see an H right here. It's going to be 1P-H. All the other inverters should say 1P-S. But they're also going to say P1, 1. So that's one phase. It's important if you have these paralleled that when you're turning them on, turn your master on first and turn this EPS switch on the side of it on first for your master inverter. So on the AC side of things, I'm going to show you how I am doing it. But if you don't feel comfortable with this, then please consult with an electrician. For each inverter, we have 2 hots, or a black and a red. We've got a ground, which is green, and we've got a white, which is our neutral. On the left side here, this is our neutral bus bar. We're going to connect our neutral wire here. We're going to connect our green ground wire to this bus bar on this side, or the ground bus bar. A really nice thing about these inverters is they have a lot of room in here, so you can manipulate the wire pretty easily. Now I am using 8-gauge wire, but I think you could probably fit 6 in here if that's what you wanted to do. I need enough on both sides, but I want to leave enough wire just in case you need to cut these at all. We're going to connect L1 to the red and L2 to the black on this left side breaker right here. Always give your wires a tug to make sure that they're not going to go anywhere. Over here on our sub panel, I'm going to connect the white wire to our neutral bus bar. And since this is a sub panel, our neutrals and our grounds are separate. Now I'm keeping all my line 1s red and all my line 2s black. So for this red, I'm coming into the top side of the breaker. And for the black, I'll go on the bottom side of the breaker. And you need to be consistent. That needs to remain the same for every other inverter you have connected into here. So we have black on the bottom, which connects to this side and goes back to black to our main panel, and red on the top, which connects to this side, our neutrals to the neutrals, our grounds to the grounds. Here's the finished product for now, and you can see the space down here gives you the ability to coil up all of the communications cables. We've got all of our AC wiring and DC wiring taken care of on that inverter, as well as this inverter, and our panel is completely wired. Now that we have the basics programmed, we're going to turn everything on and see if it's working, and it'll power the house. The rest of the settings I'll save for another video. We have our batteries connected. This inverter is on. Let's click this one on over here. Wait for it to fire up. Then I'll click its EPS switch. There we go. Now I'm going to turn the solar on. You just heard the fans kick on. Now let's manually switch the house back from the grid to these inverters and see what happens. Okay, not sure if you saw a slight light flicker, but we are on solar power. All of the loads that we were running this morning, including all of our mini splits, everything else in the house, is on and running perfectly. Now it's recommended that you run your highest voltage string into your master inverter, so that's what I've done. Additionally, I'm going to have to go out, reconfigure the panels a little bit again, and run another string here into the house for one of the other MPPTs to maximize everything from my array. Now the manufacturer of this inverter, Lux Power, has a little bit different verbiage or wording that they use for their protocols in these. And I'll try to get some answers for the next video on some of the programming. But one thing I didn't see was a protocol where you could set it to, say, solar, battery, utility in that order, or any combination of that. I believe it may just sense the optimal DC power input source and utilize that first, whether that's utility, battery, or the panels. But I will get clarification for that for the next video. Well, that's it, friends. If you're looking for a lower cost system, you can get into this system with just one inverter, 2 batteries, and say 6 panels. That's probably going to run you around $3,500, give or take. You don't have to buy any of the extra breakers or anything like that, and you can be up and running very fast. This only took me less than a day to put together. I think it's a fantastic option for many who have a financial barrier to getting into solar as an emergency setup even for their house. This certainly might be the way to go for you. If you have any questions, please leave them for me in the comments section below. Now go click on this video, which is our entire playlist about now the 4 different solar systems we've set up here on our homestead. Have a beautiful, blessed day. We'll see you next time. Bye.